She's the young lady responsible for most of it, so you're welcome to give her some applause. And I hopefully know enough about the subject. It's one of the things that I specialize in, and I've got a lot of clients that think I know what I'm talking about. So let's look at what we're going to do. So a couple of questions, introduction. We'll talk about all the problems that came with Industry 4.0 in the early days, what way things improve, what makes the smart factory, some comments on real benefits, a few of my conclusions, and then some time for you guys to ask questions at the end. Please, if you have any questions, keep them to the end, because if not, it breaks the flow up for everybody else. So, this is the subtitle of what we're doing. Yeah? Can we do some of it? Are we ready for all of it? Is it going to change the world? All of these questions. So we're going to go through these this afternoon. But if we start essentially with what it is, it can include autonomous robots, simulation, what we call, my brain has just disappeared. How we connect everything together, industrial Internet of Things, improving digital security or even cybersecurity, disruptive new technologies that are coming into the industry, augmented reality. Again, this goes into sort of digital twin, which we will talk about a bit later. And for me, the biggest one is analytics of the big data. We're not going to talk very much about Lights Out Factory today. Sometimes when I do this presentation, it's one of the questions. So I've added a couple of slides towards the back to explain what my view of Lights Out Factory is and why there's probably only one starting to happen in the whole of the world. So, what do we dream of in our factories? We want to control the material flow. We don't want any downtime. We want our inventory and our work in progress to be as low as possible. Quite simply because that's money tied up in the business that's not going anywhere. Yeah? If we haven't built it, we can't sell it. So if it's just lying there on a shelf, then it's money that we're maybe paying interest on. Every unit is unique. Some kind of barcode or laser etching or marking on every board that we make, which says it's different to all of its brothers and sisters. We can make them automatically, but we have full traceability of when it was made, which machines it was made on, where the components came from, what batch of solder paste was used to make it. All of those things are possible to be recorded on a board-by-board basis. We want, and I talk a lot about this with my clients. We used to look at reject rates, and we used to look at scrap rates. And now, a lot of people, and I'm trying to educate my clients, this is your process window. You work within that window. There's no rejects, there's no scrap. Once your process starts to get towards the edge of the window, you fix the process so you stay within the window. And Industry 4.0 Smart Factory allows you to do this because it's giving you the real-time data of where trends are happening within your production. It may be a surface mount nozzle getting blocked. It may be the solder paste losing some of its reactivity because some of the flux is evaporating because it's been on the stencil a long time. But the whole aim is really to keep everything within that magic process window. We need to get data from everywhere. And I'll talk about it more a bit later, but it has to be good data. Every operator, machine, process, even the humidity and the temperature of either inside the key machines or the whole manufacturing environment, depending on how you want to look at it. And the reason why everyone is doing this. And it's a simple statement of fact. Yeah. If you want to keep being alive in this business, really, you need to keep making a profit. Everything is becoming more and more challenging. Everything is becoming harder and harder. Costs are going up. Margins are coming down. So if you're not really doing everything you can to squeeze every last dollar out of your production system, your competitors are. And we all know what that means when our competitors get better than us. Yeah. You need to integrate sensors, better controls. Obviously, the software platform is key. Optimization of the production, but also the supply chain process. You know, before COVID, we went just in time, and everybody was believing this was the best thing in the world. And a lot of companies almost went bankrupt because suddenly there was no elasticity in the production chain. You know, the secret is to keep enough elasticity, but not waste anything. And, you know, it's like staying within the process window. That's the real art of what we do. Yeah. Industrial Internet of Things, it gives you real-time decision-making, really good data analytics that are running the full time. I like to talk really about machine learning rather than artificial intelligence, but I put it in here because some people look at it as the same thing. For me, it's the machines learning from what has happened before and optimizing the process, refining the limits that they're working to, and all of these things. It's not thinking for themselves that they want to go on holiday or something. What do you need? Well, very good data. We'll talk a bit more about that later. You need something that's going to connect your legacy equipment. It's got to be open source because you don't want to be paying one company for everything that you've linked together. Again, we'll talk more about the issues that came with this later on. But it's all about accurate real-time data coming off sensors on and around your production line, and an easy way to display what they're doing. And this isn't me, but it's another old consultant, was asked, why do we need good data? And basically, my friend who's sitting here towards the back used the phrase, garbage in, garbage out. And I think most of us are aware of that. And sometimes in our life, we've come across garbage in for sure. Yeah. If you don't have good data, don't even think about doing anything for SmartFactory until you can get good, reliable, accurate, and repeatable data. And the main aims, it gets rid of all the guesswork. It gives you more efficiency. It gives everybody visibility. But the key thing in here for me, it's accountability. A lot of production lines and a lot of people historically aren't very accountable. It all like goes into the pot. A lot of people, when they look at when rejects have been made, when scrap has been made, they don't do a root cause analysis and find out what went wrong. Yeah? This system allows you to do that. This is data from Auburn University, which I find quite interesting. A lot of people generally, and this isn't just electronics, this is industry generally, didn't really think they could embrace Industry 4.0. They didn't think the equipment could talk to each other, and they had a lot of issues, they thought, with conductivity. They hadn't actually investigated, they hadn't tried to do it, but this was just like the initial pushback of it's change and we don't like it. Yeah? Unstructured data, more than 90% of the transactions were manual. That doesn't necessarily mean they were written down on a piece of paper. It was somebody physically scanning a barcode or physically having to register or do something. They all said that their biggest challenges were within the operation. They have challenges with operational efficiency. They have challenges within the workforce for engineering, which had gone up. And their growing challenge was to spend money on new capital. So these are all pretty much all the reasons why changing to a smart factory concept would give you the advantages. But they, on one hand, they said, oh, we can't do smart factory. And on the next time they say, yeah, but we've got all these problems. So, yeah, seemed to contradict itself a lot. So let's go back in history. I did my first smart factory presentation for the SMTA in Fremont, California, at the Comet facility in early 2008. So it's not new, guys. It's been around for a long time. Yeah. People didn't really grasp the concept. The people who were championing it said it's the bright new future. It sounded too good to be true. And at the time, yeah, it definitely was far too good to be true. What happened was that some equipment manufacturers, I won't mention any names because we're not going to talk brand names today, and I'm not going to rubbish someone anyway. But they said, great, we'll connect all our machines together. We'll use our own software. Customers have to buy all their machines from us, and we're going to sell them the software. So basically, yeah, this is a great thing. And then they realized, we don't have any inspection machines. So if you remember back to 2008, 2009, quite a few small inspection companies got bought by large multinational businesses. And this was their thinking. Yeah, we won't talk to anybody else. We'll keep it all to ourselves. Unfortunately, customers are not that stupid. So they said, basically, we don't want to buy all our lines from the same people. We don't want to buy new equipment anyway, because what we've got is working quite well. What are we going to do with the existing pieces of kit we already have? We don't see a benefit. And others said, yeah, it's a nice theory, but it's not really going to work for us. So Industry 4.0 went very quiet. What made the big change was 2019. IPC, Connected Factory Exchange, CFX. Yeah. Industry developed, open international standard platform, plug and play solution, standardizes machine to machine communication, also machine to business. In other words, it's going this way and it's also going this way. It was based on an existing IPC standard, and both were managed by a connected family subcommittee. So, plug and play IoT standard. It supports all different aspects, easily implemented, no middleware required. It's an enabler for Industry 4.0 because it allows data to travel upwards, and you could put it on a line. Global companies are using it in all of their factories, and the data is available at all levels for analysis. You didn't need significant investment in custom interfaces and middleware. It was a very simple exchange of information, either up the line, back the line, or up to an MES standard. And it's applicable to all mechanical assemblies. I visit clients, they use it for their box build, they use it for plastic injection molding areas of their business. They use it pretty much everywhere within the factory because it's a really nice, easy system. Not the same as Hermes, or for us very old people, SMEMA. SMEMA was a basic machine-to-machine communication. It basically said, there's a board waiting in front of you. And pretty much that was SMEMA. Hermes had a bit more machine-to-machine communication, but it was horizontal. Yeah. SMEMA's been around since 1987, which is longer than most of you have been around. Hermes came in 2017. CFX appeared March 2019. Obviously, CFX uses Hermes, and they basically work together for communicating to a smart factory. The biggest things that CFX offers: closed-loop data exchange, machine-to-machine connection, line connection, factory connection, even analytics of your whole factory. It's very easy for setting your own KPIs, the reports that you want to get out of it. It automates all the machines. It helps you with your materials management, your quality management, your planning, even preventative maintenance and material traceability. It is a very, very solid system. Fully open source. Now, I'm not a software guy, but the software development kit works within Microsoft Visual Studio. So effectively, it is free to use. There's no runtime royalties, there's no license fees, and everybody who uses it has to say thank you to Aegis, because they actually, after they developed it, a guy called Michael Ford, unfortunately no longer with us, actually gifted the code to the IPC. Over 170 products or companies are connected to it. I have to say products or companies because some companies have their products listed on the database, and some companies just list themselves because all of their products are CFX compatible. Anybody who wants to look, that's the link at the bottom. So, something else we have to thank, COVID-19, because it completely screwed up our industry. I don't know of one company that was not completely screwed up when the whole world stopped. Yeah? It helped a lot with reshoring and nearshoring, which is becoming a bigger thing now. People started to look more and more at what they were doing because component shortages made them think. It made them think, do we have too many custom components? Do we have too many components that we can only buy from one supplier? All of these things. And there was a drive afterwards to be more efficient because everybody had to try and get back all the money that they'd lost so that they could stay in business. All of this helped Industry 4.0. And now we have the wonderful trade wars. Not going to talk any more about them today because everybody's sad enough, but basically they're driving everyone to be more efficient because now not only do you have to manufacture efficiently, but you have to cope with paying a tariff as well. Okay, this is headed normal production line layout. If I was in Asia, this would be a normal line. You guys and the Europeans might look at it and say that it's backwards. We've got a loader on the left and we've got the stackers on the right, and standard machines going all the way through. Now, SPI 2D and 3D AOI are wonderful pieces of equipment these days. They're really good at producing data and information, but they only alarm if something is out of spec. So if you're getting towards the edge of the spec and you're making rejects, you're not going to know until the alarm goes off because you're making scrap. Yeah? There's no active process monitoring. There's no feedback unless the operators are stood by each machine monitoring what's going on. So rework happens, scrap happens, all of the things that eat into our businesses. So this is my recommended first step to Industry 4.0. You have 3 great sensors on your line. The SPI, the pre-reflow AOI, the reflow AOI. All you need to do is to link those to a management information system and plot some graphs and see how things are running to how they look within your process window. It's not difficult to do. IPC CFX will give you all the connectivity that you need. You just need to buy a computer and run it this way. If you want to be really clever, and as I alluded a little bit, my history is in X-ray. Outline X-ray. Don't put it in the quality lab. Don't leave it in a corner somewhere. Get all the engineers trained on it. Put it beside the production line. And if your SPI says, your SPI says we've got a few joints that are a bit thin, your 3D reflow can't, your 3D AOI can't see them because they're under a BGA. You can tell your X-ray machine operator, look at this board, but just look at this BGA. So now you're doing targeted inspection rather than random or AQL or 100%. You're actually checking the things that you think you may have a problem with. It's fairly simple. It's fairly basic. Other sensors which are good, climate inside each machine. Some of our printers, some of our pick and place now have that. Obviously, you're not too worried about the climate inside your reflow oven. You're worried about the profile. Operator login for each machine or controlling each line. This is always the big hidden cost in manufacturing. Nobody knows how efficient their operators are because nobody knows what they're doing. It can be an advantage also for the operators because you can prove that you were doing a good job. So I have no issues in doing that. You need to log your downtimes. You need to log also the reasons why, because you need to look at what you need to do to stop them from happening. We'll talk a bit more about reflow monitoring and also even surface insulation resistance testing, because a lot of this now is batch related to the boards that you're making. So being able to log and control the SIR tests and being able to prove to your customers that you have complete data sets for everything that you need to control, especially if you're in aerospace or military. These are big things. I'm sharing this now. The wonderful piece of equipment that was used, this microphone is not at its best. The piece of equipment used to do this is no longer available, but the graphic and the interest still shows you, if you don't monitor something, what can happen. These guys have a 15.1% incidence of things being out of spec or out of control within their front of their process. They're basically just monitoring the solder paste and they're monitoring the soldering. You've got all sorts of things of operator error, and it's crazy, but the number of times that I see people who've loaded tin lead paste onto a lead-free production line, it's absolutely crazy, but it happens. Solder paste being taken straight out of the fridge, and just mixed and put straight onto a stencil while it's cold. Not good. But the best one is solder paste too warm. Quick audience participation question. What do people do to make the solder paste too warm? No? Yep, they're too late taking it out of the fridge, so they put it on top of the reflow oven to warm it up. And if they're really clever, they take off the lid, so all of the activators have disappeared before you start using it. But I audit production lines for big contract manufacturers all around the world, and I can't tell you the number of times in real life that I've seen that happening. But it's a lot more than I can count on two hands. Because everybody thinks, oh God, I've got to shut down the production line because the paste's not ready. I'll just stick it on top of the reflow oven for half an hour. This is the big one now. Reflow profilers have got a lot better. A lot of the big contract manufacturers in Asia profile their oven every 3 hours. Yeah, I know it's a little bit surprising, but they're worried that one of the heaters is going to go down, one of the vents is going to block, one of the fans is going to stop working properly, and they're so, I won't say paranoid, but they're so focused on getting the best yield that they can, that yeah, they run the profiler through their oven every 3 hours, and they're running 24/7 shifts. There's even now a profile out there that looks at vibration on the conveyor belt. Components are getting smaller and smaller and smaller. They weigh almost nothing. If your solder paste doesn't have good stiction to hold them where they are, they're likely to move if you get too much vibration in your reflow oven. So the better systems are also checking this kind of stuff. So yeah, and obviously with Industry 4.0, all of this data is fed back to the central base. If the profile is getting, if the profile in the key area here is changing a little bit, they need to check the oven because definitely something is happening. Yeah. I talked about SIR information. There are, to the best of my knowledge, only 2 companies doing smart SIR. So for the interests of fairness, I've put up a picture of both of them. But any of you that are working in aerospace and military and know now that they have effective evidence as a prerequisite for SIR testing, the data becomes more and more important, and the ability to log it and store it and also analyze it becomes, I would say, almost mission critical. Because historically, the SIR tests were done a couple of days after you'd finished making the boards. And everybody just hoped and prayed there wasn't a problem. And if you were using Rose or Roche testing, there probably wasn't a problem because the problem area didn't actually get tested. But that's a presentation for another day. But yeah, now everybody wants to do it really in parallel to manufacturing their boards. I said before, this is the big unknown in most factories. And when I visit clients who are looking to do things more efficient, this is one of my first questions. Yeah, you know, what's your direct labor cost? What's your indirect labor cost? How does it vary from shift to shift, from the type of boards that you're making, and all of these questions. But especially overtime hours were always the wonderful area, because if management was there, management was very minimal, and things tended to happen a little slower. Some things weren't done quite as well as they should have been, and all of these things generally led to either, ultimately increasing cost, because it was increasing rejects, increasing scrap, or inefficiency. So either way that you played it, the results weren't so good. But with a smart factory, the workers can log in onto jobs, job sequences. They don't need to leave their workstations. There are just barcode readers. Every operator has a unique barcode. They just scan themselves in, scan themselves out. In a lot of companies, the inspection teams do the same thing. And I have 2 or 3 clients where their junior managers also are scanned in, so they know where they are in the factory and what they're doing. So they're really keeping a good level of control on everything. The great thing with Smart Factory is, sorry, my system's misbehaving itself. The great thing with Smart Factory is customizable dashboards. You set it up to do what you want it to do. If you're getting good data and some of it you don't want to analyze, don't analyze it. If you want to really drill down into some areas where you think you've got problems, then do it that way. Have a meeting with your senior management every couple of months and change the KPIs for your own guys for what you want to monitor. If you have a problem with quality in a certain area, you can really focus on that. So this gives you the tools to do all the stuff that you need to do and gives you great control over all of your labor force. Okay. Yeah, I'm there. Yeah. MES providing companies. Last time I counted, there are about 23 of them. They all have MES. It all sits above CFX, and it will all process data. Many of them are similar, but some have key differences in their approach, the quality, the information they provide, and the way they process the data. Some understand our industry better than others, because obviously an MES platform can work on any industry, manufacturing, anything at all. Yeah? Some systems can be implemented a piece at a time. Others want to shut your factory for a few days and put everything in and hope that when they push the button afterwards, things will improve. Yeah, thank you. I'm going to throw this at someone soon. If you're looking at getting into Industry 4.0, talk to several MES providers, talk to other people in the industry, see who's had good results, see some people have struggled, and make an informed decision. You're going to spend an amount of money, but the most important thing is you're risking the future of your business. Because if this all falls apart because of bad data or bad data processing, you've just spent a lot of money and you're in a worse situation than you were before you started the project. So, key benefits if you do it properly. Better flexibility, you improve your quality management. Obviously, you've connected your machines and you try and connect everything that you can within the system, even the basic stuff. Yeah, because all of them have the ability now to produce data. All of them have the ability with CFX to transfer that data to an MES system. So connect up all the things that you can do. And obviously, if you're a company looking at things like ISO 9001, then the SmartFactory data gives you a huge amount of specific information, and it allows you to win and keep a lot of the regulatory standards. Some people implement it for for IPC 610 as a manufacturing standard with all their quality engineers. Other people just keep it to the production floor. It's going to improve your efficiency for sure. As I've already said, it helps you with IPC 610 and also 13485. And more importantly for this, if you have customers that want these, they'll go to a smart factory before they'll go to a normal factory every time if they understand what they're doing. Because having the control and the data coming out of a smart factory gives them a much higher level of confidence than a factory that's running in the traditional way. Yeah. You don't have to worry about machine manufacturers. CFX lets you connect anything to anything pretty much. And if your MES system works well with CFX, then you have complete connectivity. One of the benefits is also predictive maintenance. This can be machine maintenance. It can be changing nozzles on a pick and place machine because they've got dirty or clogged. If you've got particular components that tend to leave silicon or something onto the nozzles, you'll be building a database that tells you how often a component is going to drop, so you know when to change out the nozzle before this happens. That's just a simple example, but if you put enough simple examples together, you have a very competent process. I'm going to talk now about something which, again, not my area of expertise, but I've had a lot of coaching. I've seen a lot of them running, and this is the wonderful digital twin. Effectively, it is a copy of your factory sitting up on the cloud or inside your computer. Yeah? Normally up on the cloud because it has a lot of data and a lot of information. It knows the capability of every one of your machines. It knows the efficiency that it's running at. This is what allows you to work on the predictive maintenance, but it can do a whole load of other things. I've played what-if games on this with a couple of clients who were looking to change from their, let's say, normal industry manufacturing competence to move into aerospace and military. And we just got all the data for some boards and ran the assemblies through here and found out that, yeah, the printer was good. The pick and place machine was definitely over the capacity, but also under the accuracy that was required. The reflow oven was just about on the edge of being capable because these things had larger components on them. They had bigger heat sinks, so they needed effectively more reflow zones to control what was happening. And they did all of this, and they came up with a cost of what it would be to change their line. And basically the senior directors had a meeting and had a fairly simple yes-no decision. Yeah, we can make extra margin if we go into this business. This is what it's going to cost us to do it. This is how long it's going to cost us to change over the machines. And their system even gave them a second-hand value for the stuff they no longer needed. And they did all of this remotely, but very, very accurately. Other companies use digital twin for costing because you can put the product through the digital twin. You know how long it's going to take to place all the components. You know if you need to buy any reels. You know how long all the other key processes are going to take. And you can come up with a takt time for the line. You come up with a cost for all the consumables, and you roll that into your costing process. Obviously, you have prices for the components. Again, if you've got a full digital twin that's got access to your purchasing system, you can even bring in the cost of the components. Probably the only thing that you have to knife and fork would be the printed circuit board itself, because we all know they're unique to the product. But with that exception, you can do a whole load of costings. Other companies use digital twin to decide, are they building the right size batches of boards? Sometimes if you've got a customer that wants, like, let's say 50 boards a week, it's actually more cost effective to build them all in one batch and leave them on the goods outward shelves for 3 weeks, 2 weeks, and then 1 week. All of these things you can do with digital twin. It's hugely powerful. If you have a good one, yeah, it's kind of like almost take over the world. Yep. It drives intelligent automated manufacturing, because the first thing that your digital twin will do is to tell you, oh, you may have got the wrong pick and place machine in here, sir, because if you went to something that was doing this, then you'd have more efficiency, you'd have a faster takt time, and you'd actually make more money. So it even looks at what you're doing today and says, is this good enough or not? And yeah, it can occasionally cost you money, but if it makes you more efficient, it actually saves you. And over the industry, they say, yeah, it saves billions of dollars. How it works is relatively simple. If you look at the real world on the left and the digital world on the right, effectively all you have is let's call it a copy in the ether, which is copy exact for your manufacturing process. Look in a little bit more detail. Your physical process does all the things that are in black. Your digital twin does all the things that are in gray on the left. Yeah? So some things that you can't do, obviously looking at real-time sensors and all of these things with digital twin, because it's a twin of your process. It's not linked to your process in any way. It sits up on the cloud and it's different. So it can also predict equipment failures, as we've talked about before with what IoT can do. It helps you keep everything within your process window, because it looks at where the changes are happening, and it comes up generally with the root cause for what is going wrong. And you can look at the benefits of buying a new piece of equipment and what it will do to your production before you actually sign on the dotted line and spend the money. Even if you want to change your factory layout, you can do all of that. And the big thing is, it takes any error out of job costing. It's quick, it's easy, and it is ridiculously accurate, providing you have good data. But if you want to do something in your own facilities to give you a foundation, one of the things that I make all of my clients do is make somebody responsible for each area. Yeah? You are responsible for the pick and place. You are responsible for the printer. You are responsible for the reflow of it. And if you don't have accountability, things don't tend to move forward very quickly. Again, and I've said it before, beware of garbage in, because if you do, all you will get out is garbage. The other place where I see issues are within the company's IT department and what some people call their OT department, or what I like to call the real world. Yeah? So it's basically your line engineers and your IT people not having the same view. This can be the hardest one in some companies, because both teams are 110% sure they're right. And in reality, both of them are about 80% right. But it has been an issue. My advice is start small, dream big, have a plan, have goals, try and hit all of the goals as you go through. So my advice, start with the inspection equipment, then the pick and place equipment, then reflow and solder paste, then start looking at your logistics, looking at your materials handling, looking at your work in progress, looking at your inventory. Some people do the inventory stuff in parallel because it doesn't have an overall effect, but it can have an effect on your business, because if somebody makes a mistake and you don't order one component, you have a board with 3,821 components on, and it should be 3,822, which means you can't build the board. Even if it costs 2 cents, you can't build the board. So it's important to get all the things right. And obviously we've talked about putting information onto the cloud, data security. For me, it's becoming in Asia a huge thing now. People are very worried about hackers getting into their business and basically just locking everything up until you pay them a small shed load of money. These are real achievable benefits. I queried the first one, and basically the company was in a mess. They were ordering the same stuff every month. There was no link between purchasing and manufacturing. All they had to keep doing was finding more and more space to put all the stuff they were purchasing in, and it stayed there for months. So I'm not going to say this was the result of what happens with an average company, but this is the result of what can happen if you don't have the controls that you think you have. Imagine how much money they save by getting rid of 75% of their inventory. Huh? The other big one is the flexibility. And again, people that don't do good production planning manually or with a very simple software system have very poor utilization. I mean, you guys probably have pretty good utilization and pretty good uptime on your lines. But if I tell you in Europe, there are a lot of companies that are below 30% utilization, you'll probably laugh, or you'll go, that's kind of like us. Some of the guys that are running really good smart factory in Asia have an uptime of 94%. The rest of it is just preventative maintenance, and they even include that into their plan. So they're looking at everything and being really honest. I have to say, no one could give me a really definitive on the overhead costs, but they said we save a huge amount in machine breakdowns, because when we do maintenance, the machine doesn't break down. When the machine breaks down, it might only be a small thing that breaks, but it tends to damage 5 or 6 other things as well. And this can put the machine out for 2 or 3 weeks because we can't get the major parts. So that was their justification for overhead costs. These are just a few of the guys that I work with in various locations, and they're all global factory. They're all smart factory, definitely success stories. If you work for any of these and you're not running smart factory, I'm sure it's coming to you, because these guys are rolling it out into all of their facilities. I could have put another 15 names on here, but some of them said, oh yeah, Keith, we quite like you to maybe mention us, but please don't put our logo up because people will take photos of it. And I said, well, it's the way it is. I have to say, as you've probably gathered from this presentation, I'm also a huge believer in Industry 4.0 and smart factory. This lady knows a lot of what she's talking about. Again, I like to use machine learning rather than AI. But if you look at these, for me, adaptive AI is just really good machine learning. They say that it allows factories to change production lines. Any of you who've changed a line knows that that's not quite as easy as it sounds. But what it does do is it lets you put the products that are best suited to the lines on those lines. Whereas before, when you were doing production planning, you had a space, so you just found something that a customer wanted, and you put it into that space. And it was probably not really suited to the line. By that, I mean you might have a bunch of Panasonic chip shooters that are putting down components on a 50 off run. Yeah, the setup time for those machines is going to be 10 times the manufacturing time. That's definitely not an efficient way to run a business. I like to finish my presentations with a few things to make you nervous. I've actually seen these guys working. I took out the manufacturer that they are at the bottom, and then I realized that I'd still left the Foxconn Shenzhen City in further up. But yeah, Walker S1 does everything that a person will do, including inspection tasks. I've only seen them doing basic inspection on box build, like is the right color LED here? Are the switches in? Is the screen printing legible enough? But I've seen them carrying a whole pile of heavy boxes around, either from stores out to the line. I've seen them moving stuff from end of line to test, from test to final assembly, from final assembly to packing, from packing to dispatch. And I have to say, they're really efficient. They're really clever. They're covered in sensors. You can walk in front of them and they stop. Yeah. They don't have tea breaks. They don't have lunch breaks. They don't go sick. They don't go on holiday. And as long as you keep the batteries charged, they're working in this factory 24/7. And they told me that it only takes 1 hour to recharge the batteries every 24 hours of work. So pretty impressive. I liked it when the Chinese companies stopped calling it Lights Out Factory and started to call it Dark Factory, because this slide instantly appeared inside my head. Yeah? It's a production site where machines and robots do everything. So they don't need humans, so they don't need lights, they don't need heating, they don't need tea breaks. It reduces energy, it boosts efficiency, and I have to say they're very rare globally. There's a company in China who says we have one, but nobody's allowed to visit, because obviously it's a dark factory, so you wouldn't see anything even if you went. But they say they have it running and they have it building basic consumer product. And building the product, not just assembling the board, but assembling a variety of boards, putting them all into effectively a control box, and testing the control box, and putting it in a box and shipping it. How far it's going to go, I'm not sure. But if you look at how many robots were installed in China in 2022 was the last numbers I could find, it was over 50% of the world's total of robots. So we all know China is losing some of its competitive edge because labor costs are going up. And these guys are already coming up with the next level solution. Yeah? The people are too expensive, but we'll just go over to the robots. Another thing that we come up with is we have Smart Factory, we have Make in India, we have Make in Europe, we have all of these initiatives. China started one in 2015. They didn't really shout about it, but they're doing a huge amount, especially in electric cars, new energy vehicles, and new mobile phones. They get direct support from the government. They get state funding, they get low interest loans, they get tax breaks, they get subsidies on the land if they want to build a factory. They get all sorts of things. People, the conservative people like Custer Consulting in the US, I asked John and he said it's hundreds of billions of US dollars that they are pumping into their own manufacturing. You have some of their wonderful cars out here. I mean, they're great. Just as an aside, they've managed to destroy the automotive market in Europe because Audi, Mercedes, BMW, EV, let's say $50,000. Secondhand, 3 years old, you want $30,000 for it if the batteries are still good. You can walk into the BYD showroom, you can buy a brand new BYD for the equivalent of, let's say, $30,000. So do you want to buy a 3-year-old car or a brand new, pretty good car? So no one can sell second-hand EVs. The second-hand market has gone down the toilet. So the new market for the European manufactured ones has also died. And yeah, if anybody looks at the global perspective, Germany is really fallen through a hole now. I mean, in the good times, 52% of what they made was exported, and the majority of that was automotive. I don't know the current figures because they don't want to release them. That's kind of how bad things have got. But yeah, it's, as I said, I like to end with a little bit of fear, and these guys are the ones that we have to watch going forwards. A couple of plugs. If anybody's interested in Industry 4.0, there's a great magazine called About I 4.0 Today. By all means, take a picture or just Google it. It's a periodical magazine. It comes out with a lot of good stuff. A lot of people evaluating MES systems, a lot of new people who are getting CFX compatibility, and a whole load of other stuff on what's happening in the industry. This is not a plug for Aegis. This is simply a fact that together with giving the open source code for CFX, they have a really good white paper on digital manufacturing. I know the guys that wrote it, and it's really good. It's a couple of years old now, but it's still good today. So if you're interested in Smart Factory, you're interested in I 4.0, then read the magazine and download this. If you go onto the SMTA website and you're an SMTA member, you'll find a lot of stuff in the knowledge base on, you might have to Google Smart Factory, you might have to Google I 4.0, but you'll find a lot of white papers that have been written and presented at various shows. Some people who have implemented it, some people who've evaluated several systems. So, you know, it's one of those things that we none of us probably use enough, is the knowledge base. But it's there for all of us. So if you're interested, go have a look. So I want to thank you very much for letting me talk for the last however long it was. And I'm happy to take any questions that aren't too difficult.
Pero buenas tardes. ¿Tenemos alguna pregunta, comentario? Doctor Miguel.
José Miguel de México, Juárez. So I grew up por allá. Quiero decir, my question is to see as coming from academia. My question is related to the future use of AI and machine learning fully applied in factories. So I'm thinking about if you see the specific IPC that is related to the amount of salt or paste in a pack, there are some tendency in the IPC say, well, if at least 80% is covered, it's okay. It's stuff like that, which is not too accurate for further jobs. We know that not only the covering, also the volume and the amount, the type of sorting that it is, percentage of that. So that's one thing. The other thing is
Okay, can I take one question first and then the second one? Okay. IPC produce standards and guidelines. Yeah? I had quite a battle with IPC when I was in X-ray because their acceptable limits for voiding in their current IPC, which I think was 610E, were absolutely ridiculous in real life. They bore no resemblance to where the void was within the mass of the ball. And I had a lot of heated arguments with Matthew Kelly and the people that put the thing together. And their ultimate response was, this is a manufacturing guideline. Companies are quite happy if they want to work to IPC standards, but we suggest that in difficult areas, everybody works to the requirements of their customer. And that's a direct quote. So yeah, my advice to all of my clients is use IPC as a guideline. And if you find you're having problems, then don't think that the standard is a god. Yeah, change your own limits to what your process requires and what gives you good yields. Because at the end of the day, that's what's important. Okay, second question.
The second question is related to the knowledge base that is proper find of a machine that is good or not. It's related to the knowledge of the engineers that that I see that maybe there is too much knowledge that is not written in the articles, etc. Because maybe it's like these company secrets to outperform other companies. So I believe there's like some kind of hidden secrets of that team. Okay, so do the current machines have the capability to be programmed by a specific company and team to describe more properly the product in order to have a better performance of the machine, or we are not ready yet to describe the entire knowledge base of the engineers and the machines? You see what I'm saying?
Yeah, great question. There are unfortunately two answers. The first answer is all of these systems are based on data and information. And every company should know all of the data and all of the information for everything that it builds. As I say, one of my jobs is to do production audits. And when I visit some companies, I ask a guy, why are you doing this? And, well, we've always done it like this because Bert, who retired 10 years ago, told us that, yeah, you just have to ignore what the instructions say, and this is a better way of doing it. And my simple response is, okay, change the instructions. Yeah? And that's true of all of the people doing the stuff. Unlike in this room, some of the gentlemen in the SMTA and myself are getting older. And we don't want the skill to die with us, and we definitely don't want the little tweaks that we do outside of the approved system to die either. So yeah, it has to be documented, and it has to become part of the process. And that's the only way that Smart Factory will work. And that's one of the problems that I've seen with people who've implemented it too quickly. They haven't gone with all that knowledge and all that data, and they've ended up building stuff that was worse than before they did it because nobody knew all the little extra bits. So yeah, it's a really great question, and it's one of the things that I tell clients when they're going to Smart Factory: get your data right, get your process instructions right. Your reflow profile should be the one that's set for that product. It shouldn't be that Bert knows if you tweak this a little bit, you can run a little bit faster. Yeah? Maybe that helps, but maybe you're working too close to the edge of the process window. You've just got to get everything right, unfortunately. Okay, ladies and gentlemen, any more questions?